right, all right. Hello, everyone. How are you doing? Okay, good. I hope there's still some more people coming in, probably getting out from the keynote. I really appreciate that you came here to watch my talk. I'm going to talk about build a powerful data backend for mobile and web. A little bit about myself. I'm a cloud developer advocate. So basically, I'm the interface between the people that build the technology inside of Google and people that build on the technology outside of Google. So hopefully, you guys and girls gonna take something out of this talk and build something amazing afterwards. Before I start, I want to get a little bit of a feel who am I talking to. So who of you here is a developer? All right, that's amazing. You're in the right place. Who is an Android developer? Who has done something with Firebase? All right, a lot. Backend developers. Anyone who develops with Golang? Awesome, awesome, cool. So my favorite languages are Golang and Java. So I'm gonna stick to Java in this talk to reach the biggest audience, basically. So let's get started. So if we choose the right storage, it's actually a really, really big problem. It is really hard to do. So you have a lot of things to consider when you choose your storage system. So things like, what's the object size? What's the scale that you need? What are the latency requirements, throughput, consistencies, and like permissions, things like that. So there are a lot of things that you need to consider when choosing the right storage system. Now, when I created this talk, I was thinking, like, what am I going to talk about? Or how do I going to construct this talk? So I was wondering if I should start with something. Oh, I have to get it out. Start like 20 years ago, pretty much, right? Where you had like storage systems which are mostly local. Well, things like that. Who still remembers this, right? I actually even started with the 5 1/4 sol and diskettes, but they are pretty amazing. But I thought, like, I'm not going to bore you with like history like 20 years ago. Even though it's amazing, it's really interesting, and everybody should look into that. But we are living in the now and almost in the future. So I'm going to talk a little bit about the things that you can do today. Okay? So how can I do that? Like, I didn't want to go through like a try talk in the sense of like talking you through the different options that you have, like with Firebase or with Google Cloud Platform. I wanted to make that a little bit more entertaining. So I thought about let's do this and create a sample app. Okay? So here's my startup idea. I'm a cloud developer advocate, so for me everything is about the cloud. So my startup idea is cloudy.pictures. So concentrate on one thing and do one thing well. All right? This is where I want to get to by the end of the talk. I want to have an app where you can upload pictures, right? Where you can crop and resize the picture, where you can store metadata, and then, of course, display the pictures. Right. So what do we have in terms of options? Now, I saw a couple of you are Firebase developers. For the ones that haven't been touched or have touched Firebase so far, I really recommend to look into that. Firebase gives you a lot of things, a lot of tools to build applications, especially mobile applications, be it like Android, iOS, or web application. Right? You have things like authentication, hosting, Firestore, which gives you a flexible data storage for metadata. You have cloud storage for Firebase. And you have even something that can execute server-side code called Cloud Functions for Firebase. Now, there might be situations where you have to get out of this, where you want to do a little bit more sophisticated tasks, things that you can't cover with Cloud Functions. There are limitations with Cloud Functions, and there are reasons to break out of this ecosystem. So that's where Google Cloud Platform comes in. With Google Cloud Platform, you have a multitude of tools at your disposal that you can use. On the one hand, you have compute from like bare VMs, where you can do pretty much everything that you want, almost, up to Cloud Functions as well. Right? So you have a multitude of compute that you can use to do your things. We also have a multitude of storage products under the Google Cloud Platform portfolio. Some of these products are actually the exact same products that you can use with Firebase. So you can think of that you have different interfaces to the same product, which makes it actually easier to deal with them for different use cases. So if you build a web app, it's easier to use the Firebase SDK. If you build a backend system, you can use like our client libraries on the Google Cloud Platform. All right. So the first thing, when we upload a picture, we need a place to store our pictures. So that's where Google Cloud Storage comes in, or Cloud Storage for Firebase. As said, they're both the same product. The product is actually a highly available, durable, simple, and secure object storage. What does that mean? What is an object storage? So object storage is pretty much every kind of blob that you can think of. A blob is basically bytes, right? So it can be images, it can be videos, it can be normal files, it can pretty much be any byte stream that you can find. Now, cloud storage is optimized for user latency, for end user latency. There are a lot of things that you can do. You can define the caching strategies, things like that. You can make your object storage public so that people outside can access. You can actually make it in the sense that other people pay for the access to your cloud storage system. It is integrated with our over 100 endpoints or cloud pubs that we call. So basically, if somebody comes in from, let's say, Asia or Europe, they go to the closest pub which is connected to their internet service provider, and then they go directly into our Google network. And that means the latency to retrieve objects or even store objects are minimized. So it's a really good tool for our app. That's exactly what we want to need. All right. So we're going to start with creating a bucket. So a bucket is a unique root endpoint, so to say, that you have to create to be able to store some data. When you create a bucket, you define things like the storage class and the location where your bucket lives. So in this case, as you can see here, I have two examples. Either you use our CLI GSUtil, you make a bucket, you define the storage class. In this case, it's multi-regional, and then my storage is cloudy-pictures. You can do the same with Java if you want to. So if you want to create buckets programmatically, you can use our storage APIs and then basically directly create it from your Java program. All right, next step is uploading a file. Again, very easy. If you're familiar with CP on any kind of operating system, you just prepend it with gsutil-cm, which allows you to actually multicast your upload. And then you upload a picture here to our cloud storage bucket. In Java, pretty much simple and straightforward as well. You select a file or you point to a file, you make a byte stream or byte array out of it, you put it in a bucket and create it with a name, as you can see here. In this example, I actually also gave it the content type that you can do as well. If you want to do it from web, for the ones that have done Firebase, this looks familiar. So basically, you use the Firebase web SDKs. You get the storage reference. You use a file reader. You get from your input field, you get the file name and the content, and you upload that to storage. Very straightforward. That we use as well for our app. And next, last but not least for storage, is how to read a file. And again, it's very straightforward. You can do a copy, like download it. You can use Java, the blob object, and read it from your bucket. Or on the web, you basically get a download URL, and then you use this download URL and put it in, for instance, your image tag or your background image CSS attribute. All right. So that's great. We uploaded all our pictures, or we uploaded one picture. Now, how can I do processing, right? If I upload a picture from my phone or from my camera, these pictures are large. They are like megabytes. And I don't want to serve megabytes of pictures always to my web page or to my users. That would strain the bandwidth a lot. So what I want to do is I want to actually create some thumbnails. Now, there's a possibility that you create thumbnails already on your clients, but I don't think that is a good idea. There are many reasons for not doing this. Now, I can create thumbnails on the back end, which I'm going to use, and I could trigger the thumbnail creation from my clients. I don't think that is a good idea either. What happens if you upload a picture and then you get disconnected? Or the thumbnail creation fails and you need to retry it. all this logic would be cluttering your front end and your client code. You want to do these things on the back end. So I want to use a different mechanism to actually triggering the processing of my image files. And that's where object notifications come in. So object notifications on Google Cloud Storage allows you to basically register a hook, which gets called if anything happens on your storage system. So there are 4 event types then you can hook your systems up to. It's either finalize, which is basically object create. It's an object delete. It is archiving of an object, and it's any kind of metadata update that you do on your objects. So you can hook into any of these events. And there are different mechanisms to hook into these events. There are 3 main mechanisms that you can use. On one hand, if you use Firebase and Cloud Functions, you can use the Cloud Storage trigger for Cloud Functions. So basically, if you submit your function, you can say these functions get triggered if anything happens on my bucket. This is actually integrated with the Cloud PubSub notification system. So Cloud PubSub notification also allows you to set a notification watch command on your bucket and say, if anything happens of these events that I declare, please send me a PubSub message. And then you can have a system that deals with the PubSub message. And the kind of the legacy object change notifications that are still around is what we introduced very early on in the Google Cloud Storage platform, storage product, is the object change notification. So if you register an object change notification, you basically get an HTTPS call to an HTTPS endpoint, and then you can deal with the message there as well. The nice thing about this is all this, what you're using here, if you set this up, is integrated in a way that it does all the retry. So if you don't acknowledge a successful processing of the message, the system just retries it automatically, up to 30 days. All right, so how do I set up a Cloud PubSub trigger? Here's an example. I'm using the gcloud PubSub gcloud SDK, or CLI. So I do gcloud PubSub topics create notifs. I declare a notification. I create here, in this case, a notification against my Cloudy Pictures bucket, and I say I only want to have notifications when object finalize is happening, so when an object is created. And then I declare the topic where this notification is going to be sent to. And then if I want to have a system that receives these messages, I create a so-called subscription. Here, gcloud PubSub subscription create PubSub notif sub, which basically hooks to the topic that I just created. All right. So let me show you how that looks like really quick. So I want to show you here, you see my application. Right now, it's pretty empty. If I refresh this, nothing is happening. So throughout this talk, I actually want to fill this with pictures. So I can show you, if I upload a picture here, I just select one picture. I'm going to do upload. And it's going to upload, but pretty much nothing else is going to happen. Right? So if I'm going to refresh my page, this picture is actually going to be gone. So I need to implement all the things behind the scenes to process this picture. So the first thing that we're going to do is I show you how to create this. Let me make that a little bigger. Can you see this? Thumbs up, thumbs down, if you can see that. All right, cool. So first thing is gcloud PubSub, and then I say topic create, and let's say do notif sub. Oh, that's wrong. All right. So I create my notif topic. All right, perfect. That happened. The next thing that I'm going to do is I want to actually create my watch command. So now if you have spotted, I actually named the topic differently. So I'm going to remove this here and create this notification. So now what is going to happen is actually I'm creating a notification watch on my storage bucket. You see here, the storage is named a little different because that is the storage which I actually use for my application. Now the next thing that I want to do is I would actually want to see if any messages are coming in. So I can do a notification PubSub. Oh. Sorry, gcloud PubSub notification. All right, so it's subscription. I just created a subscription. I actually need to create a subscription. I haven't done that. So I want to create a subscription, which I call uploads. Create a subscription. So now I have a subscription that actually listens on that topic. This is a little slow, so let me turn off the Wi-Fi and hope that it works a bit better without the Wi-Fi. All right, so now I want to actually listen to my PubSub topic. So I'm going to do PubSub subscription. And then I can pull. And I'm going to pull, I'm not going to acknowledge, but I'm going to pull on uploads. All right, so as you can see right now, there's nothing going to happening. 0 items. So let me upload a picture really quick again. Going to upload that picture. And then going to go back to my system, do pull uploads. As you can see here, I have a message. All right. In this message, as you can see, there's a lot of things. There's things like the ID, a self-link for it, the name, the bucket, generation ID, all these things that you can use. All right. So next thing, let's go back to the slides. So I have my bucket. So now, if I upload my pictures and processing them, I want to actually store some data around this. So even if I now process my pictures, nothing going to happen, basically. They're not going to be displayed in my web page. So I need something to actually process them and store some metadata around them. So that's where we go back and look at what is the portfolio of systems that we have available for us. And here I'm going to look at Firestore. Firestore is a NoSQL backend system, which allows you to store document-based data. And the advantage of that is actually that it's very flexible in a sense. So if you want to add some fields or things like that, you can do that throughout the lifecycle of your application. So you don't have to be very restrictive on the schema that you're going to use. You can just evolve the schema while you develop your application. Now for Firestore, again, there are client libraries which you can use from the web as well as from your backend systems. So Cloud Firestore, just to summarize again, it's very flexible. You have an expressive query language. You get real-time updates. If you use Firebase, you can basically use watch commands or basically get events for any data that has changed. You have offline support if you do a web application, and it's designed to scale again. So this is a system that can scale to massive sizes. So how do you write data to Firestore? Here's an example for Java. So pretty much everything in Firestore is async. So as you can see here, you get a document ref. You give it a name to your document, basically an ID. You have a collection document, and then you put your fields in there. To write this, you use an API future, and then you can also update fields if you want to. Now, if you read data, it's pretty much similar to that. There are not a lot of changes here. You just do on the document ref that you create, you just do a get, and that blocks till you have the data. All right, so let's see how we can integrate that to actually write some data in our application. So now we're going to switch to some code. So what I have here is my image processing service. So what I have here is I basically set up my application with Google credentials. So this uses the default credentials that you have set. Either if you run that on a GCE instance, a compute engine instance, then you have a default context, or you provide a service account, which is used to authenticate you. It's done very easily. You really need only these 6 lines to get the credential context. Now then we need a project ID. We define our storage that we want to use. So this is, again, cloud storage for Firebase. I define here my PubSub that I have defined. And I can actually use this and say, OK, I created a PubSub, which is uploads. So I'm going to use the uploads subscription that I created earlier. All right. And then this code, what you see here, is basically listening for PubSub messages. So it's, again, doing this asynchronously. Every time I get a message, I have here my message that I get. I'm going to put that into my process message function, which we're going to look into in a bit. And then if the function is actually successful, I acknowledge this message. Now, what you have with PubSub is if you can actually have multiple subscribers on the same subscription. And what happens is your message get round-robin distributed to all the subscribers on one subscription. Now, if you want to make sure that one message is distributed to multiple places and always to multiple places, then you just create multiple subscriptions. All right, so let's look into our process message. So what we're going to do here is basically I'm going to check for uploads on my image when it gets uploaded. And I'm going to show you really quick. We have here our storage system. If I go to storage, you're going to see here I have some images. That are the 2 images that I uploaded earlier. So let me, yeah. All right, and then I basically take the path, take the user ID out of this, take the file ID out of it, do some resizing. I'm doing the resizing here with image magic. So that's the reason I wanted to run this on a GCE instance, for instance. I store the sums in my bucket, as you can see here in the create function. I have like a 600 pixel wide thumbnail and a 1,600 pixel wide thumbnail. And then I just create and move this object as well to a different folder, that it's not in my uploads folder anymore. And last but not least, I just clean up all my temporary files that I had in between. So now, as you can see, I just started that. So let's see what's going to happen. Since we uploaded some pictures earlier, on this subscription, it should actually get these. As you can see now, it actually gets these messages and does all the processing. Right? So let's have a look how that looks like. So we see here that we have our messages. We can say on my storage, you can see if anything's happening. OK, we have actually uploads and raw images now. So we have images moving. Great, amazing. And then let's see if any metadata is coming in. Metadata is not coming in. All right. So let's just upload another picture and see if our metadata is coming in. Actually, I'm not writing any metadata. So I actually need to write my metadata first. So we need to look into setting this up for writing some metadata. So the first thing is I want to have my Firestore. So Firestore init. So this creates, takes the credentials again and initializes my Firebase app and my Firestore. And then next is before I move my data to the raw folder, actually let's do it after that. I want to update my Firestore metadata. So here I'm just going to add 3 fields, a process field, a sum available field, and a large available field. All right, I'm going to save this. I'm going to restart my application. Something is missing. All right. Firebase is not there. Firestore. All right, of course. We need actually to provide this here. So Firestore. And then here, I want to provide my Firestore. All right. Let's try this again. All right, so now it is working. So let's have a look if we upload a picture. OK, we upload a picture. So this is actually just a client side that I display this picture. So if I refresh, I'm going to see nothing. That's OK. I'm going to see nothing because it's basically downloading the file, doing the image magic, and then uploading the file again. So that will take a little while. So we see a new element coming in. Let's see if we get all the stuff. All right. OK, perfect. So we have now the metadata there, which means our picture was processed and first success. OK, awesome. So we have the first picture there. Let's switch back to the slides. All right. So we have our first minimal viable product, right? So we can upload the picture, and I can display pictures. Amazing. And I can store some metadata as well on it. So now, what if our app grows, right? Like a lot of people, thousands of people are starting to upload cloudy pictures. As said before, this is a very targeted app only for cloudy pictures. So now what I want to do is I actually want to reduce some cost. In the beginning, you saw I created a bucket which is a multi-regional bucket. So the multi-regional bucket is actually our most sophisticated storage class that we have. To reduce cost, I have actually different options in storage classes that I can use. There are 4 storage classes available under the cloud storage. The multi-regional one is the one that is distributed across 2 regions, which are at least 100 miles apart from each other, and gives you the highest availability for your needs. Now, if you do data processing and you want to actually process your data close to where it is living, then we recommend to use a regional bucket. The regional bucket is in one region, it's a little bit cheaper, and gives you a little bit less of an availability SLA. Now, when it comes to archiving data, we have a nearline and a cold line storage class. Nearline is pretty much if your images or any kind of objects are older than or not used within 30 days, you can move them to nearline. Then it's cheaper actually to use nearline than have them stored on a regional or multi-regional bucket. Now, if you use your data less than once a year, then it's recommended to move these to cold line. You still have the same persistency of your data objects, and you still have the same APIs, which is amazing, but the prices get down. Now, one thing which is really important to do all these things automated or in your application is something called object lifecycle. With object lifecycle, what you can do is you can define rules when objects get automatically transitioned between the storage classes. So on my bucket, I could define a rule. If an object is older than 30 days, please move it to nearline. If it is older than 365 days or older than 90 days, please move it to cold line. But I also can do that per object. I don't have to create a bucket with a specific storage class. You can do that, but you don't have to. You can actually change the storage class per object. So how does it look like? You can use it either with GSU tool and do it there, or you can use Java, as you see there, to move your object. So I'm going to show that really quick how we're going to do this here. So I have a second application here which extracts some more metadata. So as you can see here, the same setup code pretty much. But what I do is I'm reading the object, and then I'm using an SDK to get EXIF data out of it. So now when this is done, what I want to do is actually I want to move this object away. So let's see where we can do this. So we can actually do here, and then move the object. See how we're going to do this. Yeah. All right, there it is. All right, so basically I take my object, I just define a new storage class, build this, and then say okay, when my metadata is processed, I'm just going to move it to nearline. So I'm going to start this here as well, and it's going to listen on my notification as well. So now, this is a topic where notifications have been sent before. So as you can see, it starts actually processing as well. And it might throw some errors because I have deleted some object, but it basically will process in the background our objects. So let's have a look if that is actually working. So what we can have here is we have our objects, and in time, what you can see here is metadata is showing up. Right, so this gives me all the EXIF data, which I now can use to search, for instance, or build a world map where I can put all my pictures. And if I go to storage, which I'm going to do here, I'm going to go to my storage system, I'm going to go to Cloudy Pictures, I'm going to go to my RAWs, I'm going to see here, and as you can see, my pictures actually now have the storage system nearline. So even though I created this bucket as a multi-regional bucket, I'm already moving my objects into a different storage class, which is really powerful. All right, switching back. All right, so we have that. We have reduced our costs by moving our objects and saving some costs there. The next thing that I want to do is enable a business model. I want to generate some money with this, right? So the app has gone viral. I've stored a lot of pictures, and now people have asked and want to actually like print and frame, so buy, frame, and ship the pictures. So I want to enable this. Now, if I want to do this, like I'm dealing with money, and if I'm dealing with money, I need actually a transactional system. So I don't want to do this with Firestore because I think my transactional guarantees that I have with Firestore are not sufficient for what I want to do. So that's where another storage system comes in. And we have a managed storage system which is called, for Cloud SQL. So Cloud SQL is a managed RDBMS system where you can have MySQL or Postgres as the flavor. And it allows you, gives you things like automatic updates, you can do backups, you can do failovers, you can do failovers into other people's clouds, you can do failovers into on-premise systems, things like that. It is vertical scalable, so you can change your node size throughout your lifecycle of your application. And you have things like a 99.95 SLA. So how do we create a MySQL instance? Again, very straightforward, gcloud SQL instance create. You give it a name, you say the tier, which is basically the size that you want to use, and the region where this Cloud SQL instance is created. Next thing is I want to talk to my Cloud SQL, my SQL instance. So what we provide is actually a proxy which automatically authenticates you if you provided a service file. So here what you can see, you basically download your Cloud SQL proxy, and then you make it executable, and then you can run it either locally, or you can run it on your GCE instance, or if you are familiar with Kubernetes, which is a container management system, you can run it directly in your pods as a sidecar to connect to your cloud instance. That's pretty much straightforward. Who here has done something with MySQL or any SQL database? All right, amazing. So this looks very familiar. Relational schema, I'm creating a database and some tables. In this case, I'm creating a user table, the Cloud Aficionado. I'm creating a balance table, which is basically my account balance. And I'm creating a transaction table, which shows me the history of the transactions that have been done. And then I can do things like a distributed, not a distributed, but a transaction which goes across multiple tables. So here you can see I have a transaction that actually takes some money from the balance table, puts it somewhere else in the balance table, and also writes in my transaction table that this has been happened. So it's pretty much straightforward. Now the next step is my app goes viral, right? So now what we even want to do is we want to need like a scalability check. So when I build my Cloudy Pictures 3.0, I want it to be scalable for a large amount of people. So let's check. Cloud storage is scalable. Cloud Firestore or Firestore on a Firebase is also scalable. It is a multi-tenant service. You don't have to pre-provision any resources. You basically just use it with your application, and the more you use, it will scale with your needs. Amazing. Now, Cloud SQL, unfortunately, is one solution that doesn't scale with your needs. You can scale it up to a certain point, basically the biggest VM that your cloud provider, or in our case, Google Cloud Platform provides you. But if you run out of the size of the biggest VM, you're kind of stuck. There are many things that you can do. You can, of course, do sharding and build like a distributed RDBMS. But it's very challenging and costs a lot of time investment, and it's very risky. So that's now where I want to plug in Cloud Spanner. Cloud Spanner is our horizontally scalable and distributed relational database system. So you get strong consistency with it, and it scales with your needs. You can scale to thousands of nodes, and it scales horizontally, your schema permitting. If you want to learn a little bit more about Cloud Spanner, there's a shameless plug at the bottom. So if you search for TIL about Cloud Spanner, you will find a video series where I go through some of the nitty-gritties of and amazing things that we do with Cloud Spanner. So let's recap. What are the portfolio under the Google Cloud Storage or Google Cloud Platform that we have in terms of data and storage products? So we have covered Cloud SQL. We have mentioned Cloud Spanner. We have mentioned Cloud Data Store or Firestore. There are a couple others here on the slide. So if you use App Engine, you can use, for instance, App Engine Memcache. If you have a lot of data which you want to search really fast, process really fast, so you want to have like a very high read and write throughput for non-relational data, then we recommend to use Cloud Bigtable. But Cloud Bigtable has an H-based interface, so you can connect it to your like Spark or things like that. Then we also have a data warehouse system, a managed data warehouse system, which is BigQuery, where you can go and load relational data in and crunch terabytes of data with BigQuery. All right. So with this, I thank you very much for your attention. If you have any questions, please feel free to walk up to the microphones. I'm happy to answer some of your questions. And please also, if you want to, follow me on Twitter under @HostyRosty, and I'm happy to answer any kinds of questions through Twitter as well. So thank you very much for your attention. I hope you enjoyed the talk, and have a good Google I/O.